Let me quote what MISRA say. Their advice in choosing a static analysis tool is to look at tools that detect the maximum number of violations. So, for example, minimize false negatives. And the second area is minimizing the number of false positives. So let me look at the two of these in turn. False positives is clearly the reporting of violations that don't really exist. The implication here for the team is extra time and therefore extra cost. Every diagnostic needs to be assessed. It needs to be determined whether it is a false positive, and it needs to be eliminated. And this is not trivial, especially in a safety critical system where there's lots of controls and documentation associated with that. There's also a danger that they mask the real issues that are going on in the background, this noise. And ultimately, the danger is that the credibility of all the results of the tool are damaged. The development team see that this is just an academic exercise, jumping through hoops, there's no real value added, and the adoption of the tool is really half-hearted and poor. Now, clearly, the effect of false positives gets greater as the number of rules increases and also as the code size increases. And then the cost savings from the tool become very, very obvious. The other side of the coin is obviously false negatives. In many respects, these can be more dangerous, really, because they lead to a false sense of confidence. And this is highlighted by 26262 and also in the quote there by DO178. And what happens as a developer is they run the analysis, they see that no violations are reported, they assume the code is fine, and no other mechanisms put in place to have any checks for this category of defect. That's the danger. The potential outcomes are maybe the defect is identified later in the process at additional cost, or additional defect capture mechanisms are implemented as well at extra cost, or the defect escapes to the field, as we said earlier, with lots of potential additional costs. So really, the onus here is on picking a tool that's really fit for purpose. If we look at this graphically, here's a very simple representation. Along the left-hand side, you see there the false negatives. Along the bottom, you see the false positives. So here, clearly, a tool is performing well if it's the top right, with no false positives and all the violations are reported. Bottom left says the violations are missed and there's lots of false positives and lots of noise. So if I look at this example and I put this in the real world, there was some research recently conducted by Terra Labs. They looked at 11 key MISRA rules, and they looked at, I think it was 8 tools. What the Terra Labs team said, look, on paper, all the tools claimed to provide comprehensive MISRA C compliance checking. The reality was very different. So tool XYZ, I'm not saying which tool this is, 3 of the rules were found top right in green with no noise. 5 of the rules bottom left were completely missed, those violations, and the 3 on the top line were found successfully but with noise. In comparison, the performance of QAC was really very good. All 11 rules found, no noise.